Okay, so let's look at a little bit of a complicated example with that incorporates the logarithmic function, the natural logarithmic function, but also chain rule and quotient rule. The task is the following. Find the derivative with respect to x of the following function: ln of x plus 1 divided by square root of x minus 2. So before even attempting doing this problem or any other problem, we always have to stop and we have to think, what am I dealing with? I need to find the derivative of this function. So when I look at this problem, I see that there is a logarithmic function involved, and I know the derivative of a ln of x is 1 over x. So I'm going, okay, so I may be able to work with this. I see also that I don't have logarithm of x, I have logarithm of some other function, which is x plus 1 divided by square root of x minus 2. Now that function is made out of two other functions, x plus 1 and square root of x minus 2, related to each other through division. In other words, hey, I'm going to have to somehow, somewhere apply the quotient rule. And then on top of that, if I look in the denominator, I see the denominator has square root of x minus 2. In other words, it has nested functions. It has a composition of functions. First, one layer is x minus 2, and then the next layer is square root of that. So that tells me I'm going to have to use chain rule within that derivative. So all in all, I'm going to have to use chain rule twice. Once because there is a ln of some other function, and then I'm going to have to use it again with x minus 2, square root of x minus 2, because I have x minus 2 and then a square root. And then on top of that, I will have to use a quotient rule. So that is okay. Let's figure out how we're going to apply that. So the first things first, I have that ln of x plus 1 divided by x minus 2. So the derivative of that is going to be, well, first of all, what is the derivative of ln of something? It is 1 over that something, which is x1 over x plus 1 divided by square root of x minus 2. Now you may be thinking, oh, I can write that in sort of the reciprocal, but that's okay. We'll leave that for the next step. Let's just go one step at a time. So this is the derivative of ln of something. But now I have to take a derivative, multiply this by the derivative of the something. What was my something? Is the derivative of x plus 1 divided by square root of x minus 2. So I have quotient. In other words, I have a top function and I have a bottom function. The top function in the numerator and the bottom function in the denominator. So I will give myself a roadmap by just writing out the formula first. This is times derivative of the top times the bottom minus top times derivative of the bottom divided by bottom squared. So what does that turn into then? Well, let me clean up the first part. This now turns into, I'm going to rewrite square root of x minus 2 as x minus 2 to the power of 1/2 divided by x plus 1. Remember that when I divide with a fraction, it's the same as multiplying with its reciprocal. And then times, well, what was my top? My top was x plus 1, right? So this is my top. And the derivative of x plus 1 is just 1. And then times the bottom, which is x minus 2 to the power of 1/2. And then minus the top, which is x plus 1. And then times the derivative of x minus 2 to the power of 1/2. Well, here I have a composite function. So it's first I'm going to take a derivative of the outer layer, which is 1/2 times x minus 2 to the power of 1/2 minus 1, which is negative 1/2. And then times the derivative of the inner layer, in other words, x minus 2, and that's just 1. And then all over divided by x minus 2 to the power of 1/2, and then I have to square that. Okay, so let me see if I can clean that up a bit. Well, look at this. I'm going to copy the first part. I'm going to leave it for now. Although I can see, actually, I will probably be able to cancel some stuff out with the denominator of the second fraction. But let me deal with the second fraction first, clean it up. What I will do is 1 times x minus 2 to the 1/2 is just x minus 2 to the 1/2. And then minus, well, first of all, I have a half here, and I also have the negative exponent, which tells me that there is a fraction in here. And what's going to go into the numerator? It's going to be x plus 1 times 1, which is just x plus 1. And in the denominator, I have the 2 from the half. And I also have x minus 2 to the power of 1/2, moving this part that has a negative exponent into the denominator. And then down on the bottom, I have, well, square root of x minus 2, and then squared is just x minus 2. Okay, almost. It doesn't look like it's cleaner, but it will be in a minute. So I have x minus 2 to the power of 1/2 divided by x plus 1 times, well, let's put these two on the common denominator. This is just over 1. So the common denominator is 2 times x minus 2 to the power of 1/2. So when I multiply 2 times x minus 2 to the power of 1/2 with x minus 2 to the power of 1/2, I'm going to get 2 times x minus 2 to the power of 1. You can confirm that. You can see that we are good. 2 and 2 cancel out. And if I have x minus 2 to the power of 1 divided by x minus 2 to the power of 1/2, I just end up with x minus 2 to the power of 1/2. And then minus this guy, which we don't have to change because it has that exact denominator. Okay, and then divided by x minus 2. Okay, so this is x minus 2 to the power of 1/2 divided by x plus 1 times, if I put everything on the common denominator, 2 times x minus 2 to the power of 1/2, up on the top, I'm going to get what? 2 times x minus 2 minus x plus 1. Don't forget to put brackets around x plus 1 because that negative is applied to both x and the 1. And down on the bottom, I have x minus 2. So when I clean this up, I have a double fraction. So you can think of this as over 1. I'm going to get as x minus 2 to the power of 1/2 divided by x plus 1 times, on the bottom, I'm going to have, remember, inside with inside, outside with outside. So I get 2 times x minus 2 to the power of 1/2 times x minus 2. And on the top, I get 2x minus 4 minus x minus 1. So, hey, this one and this one will cancel out. And in the end, I get 2x minus x is x, minus 4 minus 1 is minus 5. And down on the bottom, I'll get 2 times x plus 1 times x minus 2. Derivative with respect to x of ln of x plus 1 over square root of x minus 2 is equal to x minus 5 divided by 2 times x plus 1 times x minus 2. Now, let me just make a note. This is only true, so on the domain of the original function. Okay, because the domain of x minus 5 over 2 times x plus 1 times x minus 2 is much bigger than the domain of the original function. What I mean by this is that if we look at the graph of the function of ln of x plus 1 over square root of x minus 2, this is what it looks like. And if I were to graph its derivative is going to be only defined on its domain, on the domain of the original function, so it will look like this. But if we are not careful to pay attention to the domain, and we just think of the function that we have derived in terms of its derivative as x minus 5 over 2 times x plus 1 over x minus 2, this is what we would get, which is not quite right. Our derivative is only defined on the interval from 2 to infinity. And that's all for this question.